All right, and we got example 2 here that says in 10-meter platform diving, you excited? The function h of t, says h of t, where h is not a variable, it's the name of the function, h of t is equal to negative 4.9 t squared plus 4.3 times t plus 10, gives the approximate height, which is the h of t, this represents the height, above the water in meters a diver is at t seconds after launching into the dive. And we want to know how many seconds elapse from the time the diver leaves the 10-meter platform until the diver hits the water. So this function here represents how high a diver is in the air after jumping off the platform after t seconds. So if we say how high is the diver, we don't know how high the diver is unless we know how many seconds it's been since that diver has jumped off of the platform. But we want to know, when will the diver hit the water? Well, if the diver hits the water, how high is the diver from the water? The diver would be 0 feet above the water, or 0 meters above the water in this case, because we're measuring in meters. So the diver will hit the water when the diver's height above the water is 0, so solve the equation. 0, because we want the height to be 0, because he's hitting the water, equals negative 4.9 t squared plus 4.3 times t plus 10. So we're going to solve this equation for when this diver hits the water, because that is the diver's height when he or she hits the water after t seconds. So now we have a quadratic equation. And why is this a quadratic equation? It's a quadratic equation because t is squared, and then we have a normal t to the first power as well. And we can't use the process of algebra that we know to solve this. And again, if you don't believe me, give it a shot. Try to solve this equation. It's not going to work with the processes that we know, so we have to use the quadratic formula. So we're going to apply the quadratic formula, where a is negative 4.9 because it's the coefficient of the variable squared. The previous example it was x, in this case it's t. Those are interchangeable. It doesn't matter what the variable is, it's just the variable is squared. So our a is negative 4.9, our b is 4.3, and our c is 10. And notice that once again this equation is equal to 0, so we can apply this a, b, and c because the equation is equal to 0. So we're going to apply the quadratic formula. So we got to remember what that mess was. That mess was negative b plus or minus the square root of b squared minus 4ac, whole thing divided by 2a. And that's what I have here. I have installed all the values that we have, a, b, and c, into the quadratic formula. So we have negative b, because b is 4.3, plus or minus the square root of b squared. b is 4.3. So b squared minus 4 times a times c, all divided by 2 times a. So now we have to simplify this mess, and we work inside the square root first. So we're going to simplify what's inside the square root. And if we simplify what's inside the square root, we get 214.49. This is not an easy number to come up with here. It's very easy to make a mistake when you're calculating this 214.49. So be careful when you're calculating or simplifying what's underneath the square root symbol, because things can go wrong. 4.3 squared, and then we take away 4 times negative 4.9 times 10. So we want to do that multiplication, square the 4.3, and then combine those two, whether or not they're positive or negative. In this case, when we do negative 4 times negative 4.9, we get a positive number. Multiply that by 10, so we're actually taking that and adding it to 4.3 squared. So be very careful when you're making those calculations inside the square root, because this number will often come out wrong. It's not necessarily easy to do. It's very easy to make a mistake. So now we have t, called t because that's what's in our equation, is equal to negative 4.3 plus or minus the square root of 214.49 divided by negative 9.8. The next thing we need to do here is find out what the square root of 214.49 is. Do you know what the square root of 214.49 is? I don't either. I have no idea what it is. So I'm going to take out a calculator and find out what the square root of 214.49 is. When I do that, we find that it's 14.65. So we have t is going to equal negative 4.3 plus 14.65 divided by negative 9.8. And then we're also going to have t equals negative 4.3 minus 14.65 divided by negative 9.8. Why do we have two separate ones? Because it's plus or minus the square root. Because once again, there's technically two square roots to 214.49, and every other number for that case. Positive and negative. So that's why we have two. So t can be two different things. Now we're just going to evaluate. Simplify what's on the top and divide it by negative 9.8, and we're going to get negative 1.1. So t could be negative 1.1. Simplifying what's over here, negative 4.3 minus 14.65, divided by negative 9.8, and we get 1.9. So t could also be 1.9. So our answers for this quadratic equation are negative 1.1 and also 1.9. And let's think about what do those things mean. Those were seconds. So negative 1.1 seconds, 1.9 seconds. At those times, the diver will be at the water. But wait a second. The diver cannot reach the water in negative time. Negative 1.1 seconds. So negative 1.1 second before he jumps, he's at the water. Doesn't make any sense. We can't have a negative time. So this is not an answer. Negative 1.1 is not applicable to the situation. Since we're talking about a diver hitting the water, that answer makes no sense because we cannot have a negative time. So we say that the diver will hit the water 1.9 seconds after he or she jumps off of the platform. So our answer here is just 1.9, and that is due to the situation of this quadratic equation.